Hello everybody, this is Zohir Chaudhary. Today's topic is about criteria air pollutant, and we'll be focusing on particulate matter or PM. So criteria air pollutants, there are 6 criteria air pollutants: lead, carbon monoxide, nitrogen oxides, sulfur oxides, ozone, and particulate matter. Today's focus is on particulate matter, and we'll be introducing PM10 as well as PM2.5, which are the 2 criteria air pollutants of concern in the US as well as around the globe. And the 10 and 2.5, as we'll later understand, it is based on the size of the specific pollutant. So particulate matter, another name is also aerosol. So aerosols are particles of liquid or solid dispersed as a suspension in the gas. In this case is the air. So when we have PM in the air, that when we have air, the air may contain liquid or solid, and this liquid and solid, as they are suspended in the air, they are known as aerosol or particulate matter. So again, it's very important to understand that this suspension, this suspended agent or stuff, they have to be in liquid or solid form, not a gas, in order to be called as particulate matter, PM, or aerosol. So for example, sulfuric acid, H2SO4, is liquid at normal ambient temperature. So this is liquid. When it's suspended in the air, it is aerosol or PM. So this is an example of a particulate matter. Dust is solid. So dust, when it's suspended in the air, dust is also known as particulate matter or aerosol. So now a quick question. What do you think whether carbon is carbon or soot particulate matter or not? So the way to think about in here is that, is carbon a gas? Is carbon liquid or is carbon solid? If carbon was gas at normal ambient temperature, then it would not be a particulate matter. But as probably you all know, carbon or soot, it is solid. So then what is soot? Soot is a particulate matter, is another example of PM. How about sulfur dioxide? Sulfur dioxide is a gas. So since it's a gas, sulfur dioxide, it's not a particulate matter. Particulate matters have large global impact, and the mechanisms, how they are formed, they get generated, and how they react with each other is still subject to a lot of understanding, so there's a lot of ongoing research, and every few years more and more standards are proposed to be able to meet the regulations. And just like ozone, particulate matter also has no threshold, which means that any concentration, even small, can lead to adverse health effects to humans. They can lead to increased morbidity and mortality, as well as for respiratory diseases, as well as increased morbidity and mortality of cardiovascular diseases. In this slide, we can see different types of particulate matter under a microscope. Here we can see particles that are deposited on a leaf surface. Here we can see an asbestos fiber in the air. This is an example of a coal particle in the air, and you can see after coal is combusted, the particles are very fluffy in here and more spherical in nature. These 2 images on the bottom, they are examples of diesel particles. You can see that small diesel particles, they get agglomerated together to form diesel chains, and together they get lodged into your lung tissue as combined diesel agglomerates. Particle sizes, they can vary, as we already know. So particles are defined by their diameter, and we have a slide following in here which you'll notice pretty soon. So in here you can see that particles that have a 10 micrometer diameter or smaller, all of this particle, they are together known as PM10 or thoracic particle. And then particles that have a diameter of 2.5 micrometer or less, they're known as fine particles. So PM10 has all the particles that are 10 and lower. PM 2.5 have all the particles that are 2.5 and lower. So you can quickly see that PM10 here has all the particle that PM 2.5 has, in addition to these other chunks. So in this wedge, you can see that PM10 has all the PM 2.5 particle plus the 2.5 to 10 category of particle, which are known as coarse fraction. So fine fraction or fine particles plus coarse particle or coarse fraction together, they form PM10 particles. Then we have another group of particles that are very, very small, that are PM 0.1, or known as ultrafine particle, UFP, ultrafine particle, and they are typically particles that are very, very small. On the top in here, we can see some of the specific sizes that you can relate to. So particles that are close to 100 micrometer in diameter, they are similar to the cross section of a hair. Particles that are 50 micrometer in diameter, they are similar to the diameter of a pin. And then particles that are in the 10 micrometer diameter, they are similar to the size of a pollen. And then you can pretty much go on and on in here. So we have mentioned about human hair. Human hair typically has a diameter of 60 micrometer or more, depending on how thick that human hair is. So if you look at the cross section of that human hair, PM10 particle are much smaller than the cross section of the human hair, whereas PM 2.5 particle are even smaller because they have a smaller diameter. So ultrafine particles are those fine particles that are very, very small. Fine particles are the size that are bigger than ultrafine. Then we have coarse particles, and then finally we have TSP, or total suspended particle. So starting from the bottom in here, so TSPs are all particles that can be suspended in the air. So they're all particles that are 100 micrometer or less, and they can all be suspended in the air. Anything bigger than that typically cannot be in the air because it's so heavy, it will fall immediately. So it'll be like in the soil. Whereas coarse particle are particles that are much smaller, 10 micrometer and less, up to 2.5, and these particles are just big enough that they are heavy, so they get settled relatively fast, so they don't last in there for very long, about few hours, maybe a day or so, because of the heavy mass, and gravity keeps on pulling them down. And this bigger particle, known as coarse particle, they get generated from mechanical process such as weathering of rocks, volcanic activities, wind erosion, by blowing soil from exposed areas, as well as ocean waves that leads to the salt in the ocean that you smell in the coast, that is known as sea salt, as well as pollen and other grinding activity in mining. They are all examples of coarse particle. On the other hand, fine particles are much smaller. They are produced mostly from combustion sources. So they have a strong human source, and they are pretty hard to remove from the air and because of their smaller size. And so they persist in the air for days and sometimes even weeks and be transported very, very far. With respect to health effects from particle, the smaller they are, the deeper they'll go. So coarse particle, typically they'll be deposited in the upper respiratory system of the lungs, and fine particles will actually go much deeper into the lung, into the alveolar regions, and cause eye, nose, throat, and lung irritation from coughing, sneezing, and runny nose, as well as shortness of breath. Can also cause pulmonary diseases such as asthma and bronchitis, as well as heart disease, and especially infants and elderly people are particularly susceptible to fine particle exposure. The smaller they are, as we mentioned, like such as the ultrafine particle, they can actually be transported deeper into the lungs and go into the bloodstream along with some of the fine particles. So with respect to health effects in adults from fine particle exposure through epidemiological studies has been shown to cause COPD, cancer, some types of lung cancer, blindness such as cataracts and trachoma, tuberculosis, as well as heart disease. And the question mark means that recent evidence has led to significant increase of heart disease from fine particle exposure. In children, fine particle exposure leads to pneumonia, asthma, low birth weight, early infant death, and recently we have also seen that cognitive impairment. So the question mark in here, it says that recent studies, they're slowly showing, and we are needing more and more evidence to link fine particles with those health effects. In the US, fine particle is a major problem. To the right, we can see all the places that have in red that shows significant amount of fine particle concentration in the air, and the green are areas where fine particle exposure is relatively safe. Whereas on this side, you can see all the places where PM10, which is fine plus coarse exposure being measured in cities. So this is a summary on the bottom, PM 2.5 here and PM 10 on the bottom here. So we can see that there's a pattern. All of the cities, major urbanized areas, they have high fine particle pollution, and in the West Coast we also have fine and coarse particle pollution. On a global scale, US actually looks pretty good because most of the PM pollution around the globe is mostly situated in developing countries of Asia as well as Africa. So you can see in here that very high PM10 pollution in most of Asia and Africa. That concludes our lecture today about particulate matter criteria pollutant. Thank you for listening.